Hi guys, and welcome back to episode 2 of what I'm calling Space Talks here on my channel. I'm InstentKarma, and we're going to be talking about the sun today. Last week we started out the series talking about Pluto and why it's no longer considered a planet, and I figured, the sun is kind of the center of our solar system, so it might be a little important to talk about. So as you guys know, it's that big old ball in the sky that we see every morning and every night, and it's just constantly going, and we're spinning around it here. So there's a lot of cool things about the sun, so I'm not really sure how to put it into commentary form, so I'm just going to start spinning out facts because I think it's cool, and there's a lot of things that lead into another here. So as you guys know, without the sun we wouldn't be alive. I wouldn't be able to make commentaries, we wouldn't be able to play video games. None of this would happen as we know it, and it's all because we lie within this sweet spot. The Earth is, it could shift a little bit one way or another, closer or farther away from the sun, and still be able to maintain life as we know it, but luckily we are in that zone with our atmosphere and everything like that, where we interact with the sun and life is able to grow here on Earth, which is something that I think is pretty cool. Now, one of the questions that often gets asked about the sun is, it has so much gravity in there, why doesn't Earth and the other planets fall into the sun? Why doesn't it just attract us kind of like a black hole? And this one, you got to reach back a little bit in time and go back when the planet was first formed. And when all these planets were forming from the star stuff, it pulled together and gained momentum in the universe and started spinning, if you will. And so what happens now is you can still kind of think of the Earth falling towards the sun, but since it has that momentum from being formed, it's constantly moving around in a free fall form, but since there's no bottom really in space, it just keeps circling around the sun in that free fall area. So if we were any closer to the sun, our momentum would have to be sped up so we wouldn't be pulled in, because the closer you get to it, the more the gravity is going to be pulling on you there. So that's why Pluto, it moves a lot slower out there in the Kuiper Belt, and it does have a longer area that it has to travel around the sun, but even if it were the same area as what we are with Earth's orbit, it would still go slower out that far because it doesn't have to have as much momentum to stay away from falling into the sun. It has that little bit, and it's out there just orbiting the sun, which is, pretty cool. So we can go back and we look at the sun and, say that gravity is intense. Well, you think that that's a lot. Let's try to calculate the mass of the sun. So if you want to think about how big it is, it's in our sky. It looks pretty big compared to Jupiter, which is the biggest planet that we have around here. You can actually go out there and see Saturn, which is another huge planet. You can go out there and see that tonight. It will be just to the left of the moon there. But we look at those and we see they're just very small specks in our sky. We figure now that the sun is about 94 to 95 million miles away, or about 150 kilometers for European guys that use a little bit more sensical measuring system. And we take that in contrast with what we have with Jupiter now. It is a lot farther away. It's about 1.5 billion kilometers and about 383 million miles away. So there is a lot of difference there, but we still look at how huge the sun is in our sky. I mean, it is amazing how big it is. And if we were to take Earth and try to fit it into the sun, we could fit it over, about 1 million times, almost exactly, into the size of the sun. So another way to look at that is that the sun takes up about 99.86% of the mass in the solar system. So if we were to take a look at this and say, okay, let's round up all these planets, squash them all together, we still wouldn't get anywhere close to the size of what the sun is. So we have about 0.14% is what all the other planets make up in the solar system. So the star that we have, being the sun at the center of our solar system, is quite amazing already. And it is one of the smaller stars in the whole universe. It's called a yellow dwarf, which dwarf alone gives you kind of an idea how small it is. I mean, there's a lot of things out there that are gigantic in comparison to even our sun. So in the whole spectrum of things, we're a pretty small speck on the map of things. Really kind of insignificant in terms of size, more or less like an ant on an anthill in the whole thing to the sun. So it's pretty interesting to me. Now, if we want to look at more how the sun works, you can basically think of it as a huge bomb constantly going off. And we already discussed that it has a huge gravitational pull and, a lot of density going on the sun there. What happens is in the very core of the star, we have hydrogen and helium constantly combusting. They're running into each other, causing basically the equivalent of an atomic bomb going off all over the place. And it's thousands of these bombs. So, take Hiroshima or Nagasaki and just put that on a huge perspective, and then we're going to be able to see what's happening over on the sun. Well, what's really cool about it is these explosions happen non-stop. At the very center of the sun, it is super dense, and these have to explode and get out to the surface. And what happens is, because of the density, it crushes on itself and causes the atoms to go back in. So it's kind of just going in and out type of thing. A bloom effect, more or less, is what you can see happening on the sun, and it just causes it to be extremely hot. In the center there, it's about 27 million degrees Fahrenheit, but by the time it actually spends the energy to get out to the surface of the sun, which is a long voyage, let me tell you, it'll be about 10,000 degrees. So it loses a lot of its energy by that point, and a lot of its heat by the time it gets to the surface. But you go outside and that's still a lot of heat coming directly down upon you. So we look at the center of the sun and getting out to the outside. Now, for the molecules to make it that far and actually have an impact on the outside of the sun, it takes about 33,000 years. So we're feeling sunlight here that's over 33,000 years old on our skin. Like, I went out to one of these graduations last Saturday, and they ended up being outside, and I sat out there for about 3 hours and ended up getting toasted by the sun. And it's just so far away and so hot that it's just incredible to think about that something like that could actually come and hit me and burn me and have this effect for so long. So, it takes those 33,000 years to get to the surface, but it's going to take another 8 minutes to travel at the speed of light to get to us. So it's 8 minutes and about 13 seconds to get from the surface of the sun to Earth. So the sunlight that's burning me is going to be 33,008 minutes old approximately, which is pretty crazy to think about. So those are just a few of the facts that I've thought about the sun, things that I've learned, and I'm going to continue here with the space topic. I'm loving doing these space talks, and it seems like you guys enjoyed the one on Pluto, so hopefully you enjoyed this one too. As always, please remember to rate these and comment. You don't got to give me positive reviews, I just like to know what you guys think. And if you guys are new to the channel, please don't be afraid to hit that subscribe button. I got a lot of stuff coming your way here in the near future. But thanks for checking this out. I will catch you next time.